Hello everyone, this is Khairul Alam Shobus from All Math Matters. Welcome to my online math class. Hello students, welcome to my another new online class. So today's topics is tangents and normals. This topics is from differentiation and this topics is so important for the O-level students. So in my lecture I'll try to cover the formulas of tangents and normals, and also I'll try to show some examples by using the formulas of tangents and normals. Okay, so first of all, what is tangents and what is normals of a given curve? Okay, so now if we consider a two-dimensional graph, that is x-axis and y-axis. Suppose this is a function y equal fx, and if we consider a tangent, so at point P, this is a point P, here this is the tangent, this is the tangent, and now if we draw a perpendicular line on this point P, that is on tangent, that is called normal. That means if we draw a perpendicular line, so this is 90 degree, so this is called normal. Okay, so if we consider this line is tangent, and if we draw a perpendicular line at point P, suppose this is the point P, and let's say this point is x1 and y1. So this is the point P and this is the tangent. Now if we draw a perpendicular line on that point, this is called normal. Okay, so now first we learn what is the equation of the tangent of on a given curve. Okay, so here y equal fx is a function that is a quadratic or any function, that means it must be a curve. Okay, so now we will learn what is the equation of the tangent. Okay, so the equation of the tangent is y negative y1 m multiple x negative x1. Now the question is, what is m? Okay, so here m is called slope or gradient. So here m equal dy over dx at point P, let's say x1 and y1. Okay, so here m is called slope or gradient. So first we need to find the slope of the given curve at point x1 and y1, then we can easily find the equation of the tangent at point P x1 y1. So this is the equation for finding the any equation of the tangents. Okay, so keep in mind here m is the important part of this formula. So first we need to calculate the m, that is dy over dx. Here y is the given function fx. After that we will use this formula for finding the equation of the tangent. Okay, so now we will learn what is the equation of the normals. Okay, this is so easy. So now we will learn what is the equation of the normals. So the equation of the normals. Okay, so here the equation is y negative y1 equal negative 1 over m x negative x1. So look at, in our equation of the tangent there was only m multiple x negative x1, but here negative 1 over m. Okay, m will remain same, that is dy over dx. So if someone can find the equation of the tangent and then you can easily find what will be the equation of the normals. Actually, the equation of the normals is the perpendicular to the equation of the tangent. So when you will find the equation of the tangent, so you can easily find the equation of the normals. So these are the two formulas for finding the equation of a tangents and normals. Okay, so keep in mind here for in this equation here the slope must be not equal 0, otherwise this equation will be undefined. Okay, so here the slope must be not equal 0. Okay, now I'll show some examples how we can find the equation of the tangents and normals from a given curve. Okay class, now look at in example 1. Now we will find the equation of the tangent and normal of the given curve. Okay, so now what is the question? Look at, find the equation of the tangent and normal to the curve y equal 3x square negative x plus 8 over x at the point where x equal to. So here look at, here the x coordinate is given, only the value of x is given for the point, but here the value of y is not given. So first we will find the value of y, then we will find the slope at point x equal to, then after that we just use the formula, then you can easily find the equation of the tangent and the normal. Okay, all this equation, what will be the solution? Okay, first you write the given curve, that is y equal 3x square negative x plus 8 over x. Okay, now we need to find the value of y at x equal 2. So at x equal to, the value of y will be 3 multiple 2 square negative 2 plus 8 over 2, or it will be 3 4s are 12 negative 2 plus 4. So if we do the calculation, it will be 14. Okay, so our point is 2 comma 14. So that means this is the point. So at this point we need to find the equation of the tangent and the normal. Okay, now next we need to find the value of the gradient. Okay, so here y equal 3x square negative x plus 8 over x. So now we need to differentiate this curve. That means we need to do the differentiation for this equation. So if we do the differentiation with respect to x, then we'll get du over dx. So here we also do the differentiation, with 3x square negative x plus 8x inverse 1. Now if we do the differentiation, then we'll get 3 to the 6x negative 1 negative 8x inverse 2. Actually here we need to memorize the formula for the differentiation. So here the formula is d dx of x to the power n, that is n x to the power n negative 1. That is the power formula for the differentiation. So here we need to use this formula. So here now we can easily find the value of dy dx at point x equal to. So at x equal to, dy over dx will be, that is m, 6 multiple 2 negative 1 negative 8 over 2 square. Okay, so now if we do the rest of the calculation for finding the value of dy over dx, so then dy over dx equal 6 to the 12 negative 1. If we do the calculation here, it should be 2, because 2 square means 4. If we divide 8 by 4, it should be 2. That means that is 9. So this is the value of m. Okay, that means here the gradient of this curve at x equal to is 9. Now it is so easy for finding the equation of the tangent and the normal. Okay, so now the equation of the tangent, the equation of the tangent. So you just Okay, now we can erase this part for finding the equation. Now the equation of the tangent at point 2 and 14. Okay, so now the formula is y negative y1. So here this is the y1, that is 14, equal m multiple. So here m is 9, there is 9 multiple x negative x1, that is 2. Okay, now if we do the calculation, then you can easily find what will be the equation of the normal, that is y equal 9x negative 18 plus 14, or you can write y equal 9x negative 4. So this is the equation of the tangent of the given curve at x equal 2. Now we will find the equation of the normal. Okay, now the equation of the normal at 2, 14. So that means at point 2, 14, what will be the equation of the normal? So we already know the gradient at point 2, that is m equal 9. So now if we use the formula, that is y negative y1, y1 is 14, equal negative 1 by m, that is 9, x negative x1, that is 2. Now if you do the calculation, that is y equal negative 1 by 9 x plus 2 over 9 plus 14. Okay, now if we do the workout of this equation, then you can write 9y plus x equal 128. So this is the equation of the normal. So so in that way you can easily find the equation of the normal of the given curve. So keep in mind, in your question this equation will be changed and this point will be changed, but if you can solve one single problem by following the proper methods, that means by using the two formulas, then you can easily solve any problems like that, because you need to just find the value of gradient, that means the value of m, and you need to find the point, then you can easily find the equation of the tangent and normal. Okay, now I'll show another example. Okay, so class, now I'll solve another example. So this is quite different compared to the first example. So here the value of x and y is not given. So if you look at the question, find the equation of the tangent and the normal to the curve y equal x negative 1 over root over x plus 4 at point where the curve intersect the y-axis. So this is the important part. So intersect at the y-axis. So we know that from geometry, when a curve intersect at the y-axis, there the value of x must be 0. So at y-axis the value of x coordinate must be 0. From this information we can assume that the value of x must be 0 at the point. Okay, so now we need to find the value of y. What is the y coordinate? Now we'll solve these problems according to the first example, actually the same method, only the equation is different. That is first given y equal x negative 1 over root over x plus 4. So this is our given equation. You can say this is equation 1. So at y-axis the x coordinate is 0. That means y equal 0 negative 1 over root over 0 plus 4, or you can say negative 1 over 2. So that means our point is 0, comma negative half. So now we already found the point, that is the point is 0 comma negative 1 over 2. So now we need to find the equation of the tangent and equation of the normal at point 0 comma negative half. Okay, so first we need to find the value of gradient at point 0 comma negative half. Okay, so for solving this equation we can erase this question. Okay, so first we need to find the gradient. Okay, here y is given, so now y equal x negative 1 over x plus 4. So now here we need to do the differentiation. Okay, so we can differentiate the both side with respect to x, then it will be dx of x negative 1 over root over x plus 4. So here this is the division rule of differentiation. So keep in mind you must need to know the rules of differentiation. Okay, so now dy over dx, so here if you do the different rules of this differentiation, so what is the rules of this division rule? U over v, so this is v square, v multiple du by dx negative u multiple dv over dx. Okay, so this is the formula. So if you use the formula, that means if you consider the denominator is v and the numerator is u, then you can easily find the differentiation, that is v square, that is x plus 4 whole square. Okay, so now root over x plus 4 multiple ddx of x negative 1 negative x negative 1 ddx of root over x plus 4. Okay, so now if you do the differentiation, then the denominator should be only x plus 4, because if you do the square, then square root and square will be cancelled. So and here x plus 4 multiple, if you do the differentiation, x should be 1 negative 0, here 1 is a constant, so when you do the differentiation of any constant, that should be 0. So the second part x 1, so look at here, this is the root over x plus 4, so here you must use the chain rule. Okay, so root over x, so now we can use the chain rule directly, that means if you consider this root x, so the formula of root x is 1 over 2 root x, and if you do the inside value, do the differentiation again, it should be 1 plus 0. Okay, so now we need to do the calculation of this part. Okay, so now then we can write here dy over dx equal, so you can multiply this, then it should be root over x plus 4. So here negative x negative 1 over 2 root over x plus 4, and the denominator should be x plus 4. So now dy over dx, if you do the LCM of the numerator, it should be 2 root over x plus 4, and then if you do the multiplication, it should be 2 multiple x plus 4 negative x negative 1, and the denominator is x plus 4. So here dy over dx equal x plus 4 and multiple 2 root over x plus 4, and if you do the multiplication of these 2x plus 8 negative x negative plus, that is negative multiple negative is positive 1. So finally dy over dx equal 2x negative x, that is x plus 8 plus 1, that is 9 over 2 multiple x plus 4 root over x plus 4. So this is the differentiation. Actually here the calculation is quite long, because the given curve is quite complicated. Okay, so now we can easily find the value of m, that is the value of gradient at point. So we already calculate this point 0 comma negative half. Okay, this is the our point. So now at 0 negative half, the value of m, that is dy over dx, equal. Okay, now if we put the value of this, that means x equals 0 in this equation, then you will get 0 plus 9 divided 2 multiple 0 plus 4 root over 0 plus 4. There is no y in right hand side, so you just put the value of x only, then you will get 9 over 2 4 is 8 multiple, if you do the square root, that should be 2, that is 9 over 16. Okay, so that means the value of m is 9 over 16 and our point is 0 negative half. So now you can easily find the equation of the tangent and the equation of the normal. Okay, so our point is 0 comma negative half and m equal 9 over 16. So okay, now the equation of the tangent. So just use the formula y negative y1. So y1 is here negative half, so it should be negative half, equal m multiple, that is 9 over 16 multiple x negative x1, that is 0. Now if you do the calculation, y negative negative, that is positive half, 9x over 16, so it should be 2y plus 1 over 2, 9x over 16. So finally it should be, you can cut this, that should be 8, so 8 to the 16y plus 8 equal 9x, or you can say 16y negative 9x plus 8 equal 0. So this is the equation of the tangent. Okay, so now we can easily find the equation of the normal of this curve. So just use the formula, then you can easily find the equation of the normal. Okay, now I'll show this equation of the normal. So the equation of the normal at point 0 negative half, that is y negative y1, that is negative half. Here only the gradient will be changed, that is negative 1 over m, that is 9 over 16, and here x negative x1, that is 0. So you just do the calculation, nothing else. So plus half, the calculation, it should be reciprocal, it should be 16x over 9. Okay, so now if you do the workout of these, that is 2y plus 1 over 2, here is 16x over 9, or 18y plus 9 equal negative 32x, or you can say 32x plus 18y plus 9 equal 0. So this is the equation of the normal. Okay, so in that you can easily find the equation of the tangent and the equation of the normal. So class, if you practice these two sums properly, then I think you can solve any kind of problems from tangent and normals from the differentiation. Okay, and this is so important. So I believe that you must practice these two sums properly, and also you should practice more sums from your book. So class, thank you for watching this lecture. So we will meet again in our next lecture. Okay class, thank you everyone.